Hello everybody, welcome back. In this video we are going to learn about water resources. Okay, you may have heard about this term before, hydrologic cycles, or probably you've heard about or you've probably seen this image before that illustrates hydrologic cycles. So it's a very simple concept here. If we start from the ocean here on the right side, obviously we know we have lots of water in the ocean, and there could be evaporation process going on that changes from the solid phase to gas molecule of water molecule, right? So we have lots of water getting evaporated because of the heat from the sun, and then it creates clouds, and the clouds goes to the land right here, and it actually allows the precipitation to occur here on land. Okay, so what happened here is that once we have precipitation in the form of rain or snow, once those water molecules touch the surface of the earth, it actually has two options. The first one, it can be part of the surface runoff. Okay, surface runoff is the water that you see flowing on the surface of the earth, and that could be part of the flow of the river. It could also be part of, flows of water in the streams and many things. Okay, another option for that water that has touched the ground, it actually can go into a further process which is called infiltration. Now, this process is the process where water soaks into the ground. It actually seeps into the ground and become part of the groundwater system. Okay, so and that is something that we are going to focus more in this lecture, which is about groundwater system. But one last thing that I want to mention here is that both the surface runoff and the groundwater flow, they both will eventually end up here back in the ocean, completing their hydrologic cycles. Okay? All right, drinking water. Where is it from? It's definitely endless, right? Obviously, no, right? And we all know that the answer to that question is not endless. It is not endless. Okay, so I would like to take this opportunity to actually just, for all of us to reflect, okay, that in other parts of the world, there are people who do not have any faucet at their homes. Okay, so many people, especially those who live in the well-developed countries, for example, here in United States and other countries, a lot of people take a lot of things for granted. Okay, forgetting that there are people who actually needs to put more effort in order to get something that we enjoy every day. For example, water. All right. So here people are looking for water in other parts of the world, and look at this. These are a queue of bucket basically. All right. Sitting next to a well, for example, here, maybe they have water, but the water doesn't flow constantly. Maybe they have to wait for some time in order for water to get back, so then they can get the water out of the ground. Okay, and not everyone has indoor plumbing as well. Indoor plumbing is just luxury in other parts of the world. And this is something that we need to realize, that there's a lot of things that we take for granted, including the use of fresh water every single day. Okay. Now, why do humans need water? Well, obviously, we know that humans need water for many things. For example, just to mention a few, we have agriculture activity, industrial activities. These are the things that need lots of fresh water. Okay, household needs, as well as recreational activities. All right, so these are some activities that require fresh water. Okay. For example, if we take a look at the U.S. freshwater use, average home uses at about 100 gallons per person per day. Okay, and 70 gallon of it might be used outdoor, and then 30% of it might be used indoor. And as you can see here, this is a nice illustration that actually tells us something about the use of water. Okay, the most is let's see, 26% here for the toilet use, and then we have laundry 21%, and then we take shower every day 17% of the indoor use, and then we turn on faucet every single day 16% of fresh water use indoor. So we use fresh water every single day, and that is the reason why we need to talk about it. Now, because humans require water, therefore humans just start to think about on how to get water and how to preserve water in order to fulfill their needs. Okay, so therefore modern societies have altered the landscape to exploit the surface water by building infrastructures. For example, here in this picture right here, we're looking at a dam. Okay, a huge dam that actually holds and creates a lake right here that might hold, I don't know, maybe millions of cubic feet of water here in this lake alone. Okay, in order to actually preserve the water for the local use, they might distribute this water later on for local townships that they have in this region. Okay, so by building these infrastructures, obviously it would involve alterations or changes of landscape. So therefore there's an interaction here between the human needs and the environment itself. So for example, if you take a look at the case of Colorado River, Colorado River is one of the rivers in the United States that have been heavily used for water supply. Okay, one thing you need to know is that the river flows through 7 different states and Mexico, and it ends up here in the southern part of this map right here in Mexico. Okay, and it is sourced by Rocky Mountain snowmelt. So it started out from this region right here, Colorado region, Utah state, and it serves at about 30 million people that live along the path of this river. All right, and some of the states that it goes through have dry climate. So for example, Arizona, we know Arizona has a very dry climate, and even though they have a very dry climate, but a lot of people live here in these cities right here, so therefore they still need water. Okay, and where do they get the water from? They also get the water from the Colorado River. Okay, now because of the water being used here in the upstream region, all right, in the Colorado, Utah area, and then Arizona, for example. So therefore, the water that ends up here in the southern region right here in South California has a very occasional flow. So it has a very little flow. I actually have an image of that later on that you can see. So some of the issues associated with the Colorado River is that we have an increased water demand. Definitely. We have irrigation, we have hydropower. These are all the things that require water. And then the states that the Colorado River goes through, some of them are fighting over legal entitlements to maintain the flow of the Colorado River. Okay? And climate change. We'll talk about climate change in other videos, but these things will decrease the flow by 5 to 20% in the next 40 years. So there's an obvious threat on the river, on the flow of the Colorado River. And this is how Colorado River looks like, because there's a lot of people that require water from this river, from this particular river. So therefore, it requires a good management of watershed. And this is how it looks like. There are multiple dams along the way. For example, we have the upstream dam right here in the Flaming Gorge Dam and Lake. We also have the midsection right here in the Lake Powell, helped by Glen Canyon Dam here. We also have Hoover Dam, which is located in the downstream parts of Colorado River. So we have multiple dams being built along Colorado River, and these dams may impact the ecosystem of the river itself. Okay. This is also another thing that I would like to mention, that the buildings of dams and reservoirs and other infrastructures that along this river have basically, caused, you know, some issues. Uh, because the water distributed to many areas along the river flow. For example, in the Palo Verde Dam, water irrigates about 120,000 acres in California. Now, because so much water is being used from Colorado River itself, then the river, as a result, the river that finally reaches Mexico becomes very shallow and very salty. Okay? Look at this, and this is how it looks like. Compare this image right here with that image right here at the top. You can see that the downstream area of Colorado River becomes very, very dry actually, become very shallow and become very salty. Because in some parts of the of that region, because they have a salty water, so therefore they have to build some facilities to actually deal with it. Okay, so for example, this is a Colorado River desalination plant in Yuma, Arizona, to treat the river water that have become salty through irrigation practices. Now, Los Angeles, California also has, issues with fresh water, and this is something that we've probably heard about, through the news. So, for example, if we take a study case in Los Angeles, Los Angeles is a big city, is one of the big cities in California, and it is actually located in semi-arid desert region with very little native water. So it has a very little water resources, native water resources around that city itself. But the problem here is that the population, went crazy. All right, it started out for about 5,000 people in 1870 to about 100,000 people in 1900s to currently 10 million people. More than 10 million people now live in Los Angeles area, and every single individuals who live in the cities needs water every single day. Okay, so the city face a very serious water shortage, and this is something that we always hear in the news very often, especially during the summer, right? So therefore they decided to build 200 plus miles aqueduct system from 1905 to 1913 to transport water from the eastern Sierra Mountains to Los Angeles using gravity. Okay, so it uses gravity. So this aqueduct system simply uses gravity to flow the water, to allow the flow of the water from the higher elevation to lower elevation in Los Angeles. So let's take a look at this map right here. So this is the location of Los Angeles right there, and they got most of their water coming from Owens Valley right here in the eastern part of Sierra mountain range. Okay, so what happened here is that they simply build a water line from higher elevation towards Los Angeles, just flows the water that allow the flows of the water from higher elevation to lower elevation in Los Angeles. Okay, so here are the three major aqueduct systems that we have in Los Angeles. One here is the Los Angeles Aqueduct System from Owens Valley here, and it flows down towards Los Angeles. It also has another aqueduct system called California Aqueduct System right here that goes parallel to the length of the state. And it also have another one here at the south, which is called the Colorado River Aqueduct System. Okay, so the Colorado River Aqueduct System actually intercepts the water right here in the Colorado River and making the water flow down to Los Angeles area right here. Okay, and that's probably one of the reasons why in the downstream area right here we only have occasional flows of Colorado River, because obviously some of the water are being intercepted right there, and this is not the only one. There are lots of interceptions along the flow of Colorado River all the way to the upstream parts of it. Okay, and here on the right side you see an example of aqueduct system, and as you can see here, it literally just uses gravity from higher elevation to lower elevation, allowing the water to flow. Okay, this is also another view of Los Angeles aqueduct system right here. You probably have, you know, if you travel from Nevada area, I've traveled from Grand Canyon all the way to Los Angeles. You know, you will see something like this along the way. And this is what we have in the news. This is probably the news for, you know, at about 2020-ish air time, um, about 3 or 5 years ago. This is what we hear in the news, that California has the lowest deliveries on record, and it has 8-year Colorado River drought, and it actually gets much worse by now, and it has the lowest precipitation on record and many other issues associated with freshwater use in California. So therefore they need to do something about it, and this is something that we always hear again in the news. And that's just wrap up the introduction of this topic right here, and in the next one we're going to focus more on the technical part of groundwater system. Okay, and I'll see you in the next video. Bye bye now.